Hello and welcome to this video. In this session we are going to talk about method of sections in order to calculate the internal axial force of members in structures in a form of truss. And let's start off with our first example. In this question we are going to calculate the internal force of CG, this member, and GH, this member. So first of all, let's calculate our support reactions Ry and Fy. Already we know that Rx is equal to 0 since we don't have any external horizontal force acting to our structure. So Rx is equal to 0. By symmetry, we know that Ry and Fy are equal. So along y direction, if we are going to develop our equilibrium equation along y direction, there is just one unknown, and since they are equal, so simply we can calculate the amount of our reactions. Okay, what we have here is four forces acting downward. So by solving this equation, it turns out to be Ry and Fy are equal to 3L over 2. Okay, right now with knowing our support reactions, let's cut through the structure and cut our desired member, which was this diagonal and lower chord in our structure. Okay, so just consider the left hand part of the structure, and we are going to calculate the amount of the CG and HG. If you pay attention, we can see that if we write equilibrium equation horizontally, we have two unknowns, but if we write it vertically along y direction, our only unknown is the vertical component of CG, so we can calculate the amount of it. So let's write it. What we have is Ry that we already calculated, so it's not unknown anymore, and L over 2, which is downward, minus L, and again we don't care about the right hand part, just left hand part and the internal forces. In method of section, we should pay attention that our support reaction and external forces should be in equilibrium with internal force. Okay, and CG times 3 over 5. What is time 3 over 5? Let's imagine this triangle. This member is 3 meter and our bay or span is 4 meter. So our base of this triangle is 4 meter and the perpendicular side is 3, so this one is 5. Simply shows the vertical component of CG. Or likewise, we could consider this one as a theta, this angle, and write the sine of theta instead of 3 over 5, but this one is easier. Okay, to solve this equation, it turns out to be CG equals to be 0. So this force, according to this loading with this arrangement, is 0 force member. The second member which we are interested in knowing its force is this member. By writing moment equation about point C, we can calculate the amount of GH since our two other forces are intersecting at point C, this point. So the only unknown is for this equation is GH. Let's write it down. What we have here, the resultant of these two forces, Ry was 3L over 2, so the resultant is L and upward, and L times 3, which is the distance between the force and the point C. Why negative? Because we assume counterclockwise as a positive direction. Okay, so because this the resultant, which is upward, because alpha is greater than this external force, is L and it's upward and it's causing clockwise rotation around this at the point of C. Okay. And what else we have already, we told that these two members are passing, and this external member also passing the point C, so they don't cause or generate moment around point C. The only member or force causing moment around point C is GH, and GH, so times the distance, which is 3, we can calculate the amount of GH, which it turns out to be L. So let's move on to our next question. In this question, we are going to calculate the amount of Hn, the internal force of Hn, which is our diagonal member in this structure. I cut through the structure with a dashed orange line, as you can see, and I assume the direction of internal forces like that. GH is compressive, HN is tensile, and NM is compressive, but it doesn't matter. Later you can see that your first assumption is right or wrong. If it was wrong, you can modify it subsequently. Okay, let's first of all see the structure as a whole and determine our support reactions. Similar to our previous example, Ix is equal to 0 and Ry and Ky by symmetry, we know that they are same or equal. So each of them is equal to half of the sum of our all external forces. The sum of them is 8L, so each of our support reaction is 4L. So one of the advantages that method of section has over method of joint is that we can take advantage of the moment equation. For example, for such questions that we have three unknowns and we're going to determine one of those unknowns, like here, uh, our two unknowns are passing one point, which here is z. If we write moment equation about point z, actually we can get rid of these two unknowns, and after writing moment equation, only one unknown will be left for us to calculate. So just by writing one equation, we can determine the amount of Hn. Okay, in order to write the moment equation, we need to know the length of this distance. Let's we call it x from point K to Z. Okay, by similarity of triangles, we can determine the length of x. We know that this bigger triangle OFZ is similar to this smaller triangle KJZ. Okay, so the perpendicular side of the smaller triangle over the perpendicular side of the bigger triangle is equal to the proportion of their bases. Here the smaller is x, and the length of base of a bigger triangle is 12 plus x, this length, which gives us x equal to 6 meter. So right now, with knowing the amount of x, we can write a moment equation about point Z. What forces we have in order to write the equation? One of those is L. The distance is 12 meter from this acting point to Z. we have two bays. Each of our bays is 3 meter long, and two 3 meter and one 6 meter, so the distance is 12 meter. Then we have this force 9 meter and this force 6 meter, and our support reaction curve y that already we calculated, it was 4 L and times x, which is the distance between car and z, which is 6 meter. Y negative because car y is upward and the moment causing by this force about point z is clockwise, and we assumed our positive direction is counterclockwise, so we show the direction of this moment by negative sign. Okay, we write our all external forces and our support reaction. Only our unknown is left to write the moment causing by this unknown about point z. As you can see, this member is diagonal. In order to simplify our calculation, we can decompose this force into its x and y components. Uh, we can decompose this force at any point that you like. It doesn't matter, but in order to simplify further our equation, I decompose it at point n, because at point n, because we can see that if we decompose it here, our horizontal component is passing point z, so it doesn't cause any movement about point z. We can simplify our equation even further, but similarly we could have decomposed our force at on point h here, but if we decompose it here, our equation, because our two components cause moment about point c, and our calculation would be a bit longer, but both of them are right. Okay, in order to write the vertical component of the internal force of Hn, we need to know this angle theta, or similarly, if we know the side of this triangle, this one, we can calculate or determine the vertical component of this force. We know that this distance, the bay, is 3 meter, and again by similarity of triangles we can calculate the perpendicular side of our triangle, which is 4 meter. When the perpendicular is 4 and the base is 3, so our hypotenuse would be 5 meter. 16 plus 9 would be 5. Okay. By so right now we know that vertical component of nh is nh times 4/5, and times 15 meter. We can calculate the amount of moment caused by this force about point z, and that's it. This is our equation. By summing all of our terms, it gives us nh equal to 0. So nh is again 0 force member like previous example.